All right, you made it. This is the last video of the three. What we're going to be doing is we're going to be trying to figure out the distance between a point and a line. So this is essentially what we have. We have the point right here, x1, y1, and we have this line right here. Remember, the equation to line can always be written in standard form, ax plus by plus c equals 0. I know in Algebra 1 you learned ax plus by equals c. It doesn't matter, you just throw the c over there. The coefficients can essentially be fractions or not fractions. It's your choice, obviously. Not fractions can make things a little bit easier, so that's what I would be trying to accomplish. Now, the way that you approach this problem back in geometry, or even in the beginning of this year, what you would have to do is you would actually have to figure out what the slope of this line is here, and then because you know you want to find the distance, you'd have to have the perpendicular slope, and then you'd come up with this line right here that you would have to find. So you'd find the equation of this line, and then figure out where this line intersects the red line. So the purple line intersects the red line at that point. You'd have to calculate what that point is, find the using a system of equations, and then you could find how far the 2 points are from each other. It was a very taxing problem. Like, it took quite a bit of time. I would say it's probably one of the hardest, or most time-consuming, I should say, most time-consuming geometry problems you can encounter. It took quite a bit of time, and it took a lot of understanding. Like, you had to understand how to write the equation of a line, how to find the perpendicular slope, how to find the point of intersection, meaning that you had to solve a system. And then in the very end, the fourth thing you'd have to do is you'd have to use the distance formula between the point of the intersection and the original point that you have. However, there isn't a more advanced way to do this. The proof is kind of ridiculous. It takes a bit of time, so I'm not going to be able to show you the proof. If you guys have questions in class about it, more than happy to show it to you at lunch or after school. But right now what I want to do is I just want to take a look at the equation. And what the equation does is it helps us figure out what is the distance between this point right here and this point on the line that is perpendicular to the line when drawn between those two. And the equation is this, is that the distance d is equal to, and this is where it gets a little tricky, okay? So the distance is equal to, so it's got a fraction, and in the denominator, what I want you guys to write down is the square root of a squared plus b squared. So the square root of a squared plus b squared. And then the top is going to look a little tricky. The first thing is the absolute value. I'll explain why the absolute value has to go in there. And then the absolute value of the coefficient a, so the coefficient a from right there, times, and this is where it gets kind of goofy, times the first point's value. So the coefficient of the line times the x value of the ordered pair plus the coefficient of the y value in your line times your y value in your point. And then plus c. And that's it. It's actually fairly straightforward. It's not a ridiculous equation. It just uses pretty much all the numbers from the line, and it uses the ordered pair, and it comes up with this. Now, how we get this is a little more complicated, but this is it. This is really the equation. So let's practice using it. Our first example number 1, is that we have a line. So the line that we have is, oh geez, I didn't make this up. Yeah, so we'll just make up one. 4x, let's say 4x plus 2y is equal to 7. 4x plus 2y is equal to 7. And then we have an ordered pair. Now the ordered pair that we have is the point, let's go with something fairly big, 10 comma negative 1. 10 comma negative 1. And what we want to do is we want to find how far is this point to this line. And we just use the distance formula. So we set up our distance formula. So we're going to, distance formula. We set up our equation from up above. The distance between the line and that point is equal to the absolute value. Oh, I just realized. We can't use it because it's not in the standard form up there. So we want to make sure we get it in the standard form first. 4x plus 2y minus 7 is equal to 0. And now we can start plugging it in. So we're going to say that the distance between the blue line and the point is going to be the absolute value of 4 times 10 Okay, 4 times 10 plus 2 times -1 plus -7, or just -7 right there, divided by the square root of 4 squared plus 2 squared. So if you're going through this, what did I do? Well, all I did was take A, B, and C and put A, B, and C, just like that. A, B, and C. And then I multiplied the coefficients of the x by the x value at the point. So I multiplied it by that guy, and I multiplied the coefficient of the y value by -1 right there. And that's it. That's all we're doing. All right, so now let's go ahead and simplify this thing, and this gives us, we got 40 minus 2 minus 7, so we get 31. So we have 31 over, and then we have to simplify this. 4 squared is 16, 2 squared is 4, so we get the square root of 20. Now, if this was calculus, I'd say, this is a great answer. Leave it, done. Unfortunately, we're not there yet, so I want to practice rationalizing because that is something that's going to be on the final this year. So we want to make sure that we can rationalize this thing, also simplify it. So we're going to simplify this guy down to 31 over 20 is just 2 square root 5. And now we multiply the top and bottom by root 5. And our final answer comes out to 31 square root of 5 over 10. So our distance between the point 10, -1 and the line 4x plus 22y might equal 7 is going to be 31 root 5 over 10. All right, so this is the final video. You should have all the information you need now to complete the assignment. Once again, if you have any questions, please hit me up or talk to me in class. Have a great night, have a great evening, and I'll see you guys when I see you.